Hello everyone. In this video, I would like to talk about one of the important points on a triangle, which is circumcenter. Circumcenter, for any triangle, we can draw a circle that passes through the corner of the triangle. So we have a triangle and we can draw a circle that passes through the corners of this triangle. That circle is the circumcircle. That's close enough. This circle is circumcircle. And the center of this circle is the circumcenter. The center of the circle, let's say somewhere here, O. O is the circumcenter point, O. And the circumcenter, let's say it's this ABC triangle, equidistant to each corner. OA is the circumradius, and similarly OC is the circumradius, and OB is the circumradius. Circumcenter is equidistant to each corner. So how we can locate this point? And to explain that, we have to explain, first of all, perpendicular bisector theorem. Perpendicular bisector theorem. The theorem says, if we have a line segment, let's say MN line segment, we would like to cut this line segment in the middle and perpendicularly. That's the perpendicular bisector. The midpoint of MN is, let's say, point X, and MX is the same as XN is the midpoint. And we would like to draw a line that passes through X and cuts this line perpendicularly, line segment perpendicularly. And the theorem says if you pick any point on this line segment, it is always equidistant to endpoints of the line segment. Let's say we pick this point, point M. It must be the distance P to M must be congruent to distance P to N. Let's explain that, why it has to be like that. We form two right triangle after we draw the line segment PM and PN, the yellow right triangle and this blue right triangle. And these right triangles are congruent. Why they are congruent? And from side angle side congruency. And they share, both blue triangles and the yellow triangle share this side, PX, and they are the same. And we know that MX is congruent to XN because X is the midpoint. This side must be congruent to this side because X is the midpoint. And the angle between is a right angle, 90 degrees, 90 degrees. From side angle side congruency, the two triangles must be congruent. And it's just then we can say that the hypotenuse PM must be congruent to PN. Great. After this theorem, we can explain how we can construct the circumcenter. Let's say we have a triangle. And the first thing is the corners are, let's say, ABC. We're gonna locate the midpoint of AB, let's say M. And we would like to draw a perpendicular line to AB passing through M, which is the perpendicular bisector. Now, if I pick any point on this perpendicular line, this blue perpendicular line, that must be equidistant to A and B. Then we are going to draw the second perpendicular bisector. Let's say this green perpendicular bisector. The midpoint of BC is N. Here CN must be equal to NB before we have to say AM is equal to NB. And then we would like to cut BC side perpendicularly and bisecting. And this is the green perpendicular bisector. They intersect at one point. And that point is this point must be equidistant to corner A, corner B, as well as corner C. Now I can draw a circle. The center is, let's say this is point O. Center is point O. The radius is OA. And this circle is passing through the corners of the triangle. Okay, close enough. All right. O is the circumcenter, OA is the circumradius. Let's construct also, this one is on GeoGebra. And I would like to talk about, you can see on the problems, the cool triple a lot. This cool triple, which is related to the circumcenter in a triangle. We have a triangle, and this is given, which is we have a point here. We're just gonna be, these are all congruent. This is cool triple. This triangle must be a right triangle because this must be the circumcircle of a triangle. Let's draw the circumcircle on a GeoGebra and explain that cool triple after that. We have a triangle, and we would like to locate the circumcenter of the triangle. Let's draw the perpendicular bisectors for the side BC and side AC. And the third one is also passing through the same point. Perpendicular bisectors are concurrent. And that point is D. And we can draw a circle now from D to B. Observe that it is passing through the corners of the triangle. And if I change the triangle, it is always, the circle is passing through the corners of the triangle. And we should make observation about, let's say the angle A is now 70 degrees. If we have an acute triangle, the circumcenter is inside the triangle. If we have an obtuse triangle, the circumcenter is outside the triangle. And if we have a right triangle, circumcenter is not easy to make 90 degrees, but it must be on the hypotenuse if we have a right triangle. And we observe that, let us assume that it's very close to 90 degrees. And from the center, D is the center of the circle, which is D is equal to DB is the same as DC is the same as DA. It is almost, let's say, right angle. Observe that we have a cool triple here that makes this is the circumcenter. If we have these three things, we have a right triangle. This is the end of the video. Thank you very much. See you in the future videos.